Assalamualaikum warahmatullahi wabarakatuh. I'm Dalia binti Hassan. So today I would like to give a brief introduction for reinforced concrete slab designed to Eurocode 2. This is the learning outcomes related to the design and analysis of concrete slab. So let me break down each of these learning outcomes. So the first learning outcome is to understand the definition of slab, types of slab, and the types of restrained slab. Okay, this focus on the fundamental concept that related to the concrete slab. So students should be able to define what a slab in this context of structural engineering, and they also understand the various type of slab which typically include the one-way slab, two-way slab, flat slab, and wafer slab, and others. So furthermore, they should grasp the concept of restraint in the context of a slab design, which refer to how a slab is supported or held in a place. So the second learning outcome is to identify all loadings or action that subjected to the slab design. So this objective pertains to recognizing and comprehending the different types of load that the slab may be subjected to. So this load can include the permanent action and also the variable action. So number 3, differentiate between the one-way and two-way slab load transfer mechanism. So this objective involves the understanding the load distribution and transfer mechanism in one-way or two-way slab. So in one-way slab, the load primarily transfer in one-way direction, perpendicular for the supporting beam and walls, while in a two-way slab, they distribute and transfer in two-way direction, both parallel and perpendicular to the supporting element. So, students should be able to distinguish how this mechanism affect the design and structural behavior. So the last learning outcome, which is LO4, is to draw a 1 meter strip of slab to be designed. So this learning outcome is entitled student being able to create a systematic representation or drawing of a 1 meter wide strip of a concrete slab that they are intend to design. So these all learning outcomes are essential for anyone that's studying or working in the field of structural engineering and concrete slab design, as they provide a solid foundation for understanding the principle and practice involved in this area of civil engineering. This is the content of the slide presentation. Introduction. Slab is a structural element with a small overall depth of thickness as compared to the width and its span L. A flat, large surface for the purpose of supporting loads. The depth is small as compared to the length and width. The bending behavior of a slab is similar to the beam. Generally, the design of a slab is almost similar to the design of the beam. Type of reinforced concrete slab include solid slab, rib slab, flat slab, and wafer slab. This slide shows the type of a system for reinforced concrete slab. So as mentioned before, there are the few types of the reinforced concrete slab, which are convention system, flat slab, capitals, drop panel, and wafer slab. So on the left, okay, we have a simply supported slab and continuous slab and also cantilever slab. Slabs are normally carrying uniform distributed load over a slab area due to permanent and variable action. So we have a permanent action, GK, and also variable action. The design of reinforced concrete solid slab can indeed be simpler compared to reinforced concrete beam design in a certain situation. So here are an explanation of the reason provided. The first one is a fixed slab width. B is equal to 1 meter or 1000 millimeter. When designing an RC reinforced concrete solid slab, the width B is often fixed at a standard value such as 1 meter. So this fits with simplify the design process because you don't need to consider variable width as you might with beams. Number two, the low shear stress in slab. Solid slabs typically have a low shear stresses that compared to beams. This is because the load is distributed over a wider area in a slab, leading to a smaller shear force except in a cases where the slab is subjected to concentrated point load. So the simplified shear behavior can make the design process less complex. So number three, less compression reinforcement, unlike beam, where the compression reinforcement, such as stirrup or ties, is often required to resist the shear and provide ductility. Solid slab generally require the less or no compression reinforcement. This is simplify the detailing and the design of the slab. And lastly, uniform distributed load. Solid slab often support UDL over their entire span, which simplify the load analysis and design. So the UDL simplifies calculation that related to bending moments and deflection compared to beam that may have concentrated load. Spanning in one way or two-way, okay, reinforced concrete solid slab can be designed to span in one way or two-way slab. This is classification that depends on the factor like a support and the ratio of the length Ly to the width Lx of the slab. One-way slabs are designed to span in one-way direction that typically supported by wall or beams on two opposite sides. So this is appropriate when the length to width ratio is significantly more than 2. Okay, the figure on the left side is shown a one-way slab. So for one-way slab, the deflect in a one direction where Ly over the width Lx is more than 2. Longitudinal reinforcement is provided in a one direction and also the load transfer in one direction. Okay, for two-way slab, okay, the deflection in both direction, okay, where the Ly over Lx is less or equal than 2, okay, the longitudinal reinforcement provided in both direction and also the load transfer in a two direction. Design of reinforced concrete slab. Slab design is carried out in the direction of the transfer load, means that the design of the slab takes into account on how the loads are distributed and transferred within the slab. So depending on the support and loading condition, slab can be designed as a one-way spanning or two-way spanning, which affects the distribution and forces and also reinforcement layout. Number 2, in many design code and practice, a standard width of 1 meter or 1000 millimeter is commonly used for simplicity and ease of calculation. So this fits with simplified the design process by eliminating the needs to consider the variable width. Identifying the length L and the width B, drawing a 1 meter wide strip of a slab helps to identify the length and the width of the slab. These dimensions are crucial for the load calculation and design. Slab as flexural member are indeed considered as a flexural member. This means that the primary modes of failure and design consideration for slab is related to the bending and flexure. So the design procedure for slab are to those use the rectangular beam, which the primary difference being the shape and loading condition. It's important to note that while this principle provides a good starting point for the slab design, the actual design process can become more complex when dealing with the specific loads, support, reinforced detailing, and code requirement. As an engineer, okay, you must consider the factors such as the variable action, the permanent action, the serviceability criteria, the deflection limit, and the reinforcement design that based on the moment and also the shear calculation. So additionally, the local building codes and design standard may dictate specific design procedure and load combination that must be followed to ensure that the safety and stability of the structure. That's all for today. Thank you for your attention.